Most of the really complex problems that need to be solved in the sciences and in technology as well as in other fields really require these days the contributions of multiple disciplines. This is designed as a facility that will enable all kinds of faculty from different disciplines and their students to come together and pool their ideas and address some of the most challenging problems in the sciences.
Since joining George Washington University, my research group has been dedicated toward finding new antibiotics to prevent the spread and development of drug-resistant bacteria. My work has focused on tuberculosis so far, but we're just starting to look at new targets in malaria. And because we can use our science to tackle this new problem, that opens up avenues for funding, for collaboration, and for really impacting tropical and neglected diseases on a global health scale.
The speed of a computer has not changed over the last 10, 15 years. It still clocks at a few gigahertz. What we do, we design an optical computer, a photonic computer. The chips that are inside the computer will run with light. That allows the computer to be much, much faster and saves a lot of more energy.
If you look around the animals that are alive today, the closest animals to us are chimpanzees and what are called bonobos. The very small difference between us and chimpanzees and bonobos is thought to have accumulated in the past 6 million years. The only way you can really get at what happened is through the fossil record. We are trying to reconstruct human evolutionary history. We have wonderful colleagues at the Smithsonian, and many of the graduate students are mentored by people at the Smithsonian. I do research with people at the Smithsonian, and it's just a precious commodity. I mean, no matter how much the internet has changed things, actually going over to the museum and opening a drawer and pulling out some bones and seeing whether you're right or wrong is really difficult to replace.
So in our group, we focus on medical diagnostic or nanotechnology for biomedical applications. So one example application is to bring medical diagnostic to the point of care, ultimately near the patient who needs this diagnostic tool. And that could save lives and also reduce healthcare costs.
Most of my research is about highway bridges. I have a patent that goes back to about 10 years ago that has been implemented in real bridges in the Midwest area and the east part of the country. Since then, I have been working on improving this system, and this system is about accelerated bridge construction. We are trying to come up with systems that are very fast to construct, they are very durable, they are gonna last more than the cast-in-place systems that we usually or typically use on bridges.
We are interested in how animals swim, big animals, but it turns out that what's happening at the very small scale, equivalent to the tiny hairs and the structure of your arm, it turns out that that has a large effect on the overall performance of a lot of swimming fish. As engineers, we tend to stick with one or two things that work, but nature has infinite solutions to the same problem. We love working with the National Zoo. What that allows is for our students to not just see what's happening in the laboratory, but to really observe the natural world. Being in DC, we have this wonderful opportunity that these animals are just down the street, so a small metro right away, and they can do field work. And it opens up the opportunity to a lot of students.
My lab's research is focused on heart disease. So more specifically on heart rhythm disorders, so basically what is known as arrhythmia, when heart is beating too slow or too fast. And currently the best treatment for that are actually implantable medical devices, such as pacemakers, defibrillators. Even though they work really well, they're implanted in millions of people, but there's a lot of room for improvement, and that's what we're developing.
This is going to be a place where some of the biggest problems that need to be addressed in the sciences are not only going to be addressed and we hope will be solved, but that'll happen right in front of our students, and they'll be participating in the excitement of that kind of groundbreaking cross-disciplinary research.